All right, so more practice factoring. Hopefully it went okay last night. I gave you, most of the questions from yesterday were just remainder theorem, like finding remainders and thinking about factors, but I did say try a few in case you have questions, so that we're going to do a few quick examples kind of thing, but then you'll have the rest of the period, if there's any time left, to do some more practice. So, and factoring, it doesn't need to be said, is always about kind of using all the information that you know and everything you know about polynomial functions or about whatever kind of expression you're looking at. Okay, so there's never a time in factoring where you might see something from a long time ago, from like grade 10 or something like that. There's no rule, and except for a question like that where it says use long division to divide. There's no rule when you're factoring that you have to factor a particular way. It's about problem solving. It's about being observant, noticing patterns, right? Whenever I start teaching factoring, it has a lot to do with how did you get there in the first place? So when you first see trinomial factoring, you would do this: x plus 5, x plus 6, and you would expand it, right? And you get x squared plus 11x plus 30. And you think, well, how did we get to the trinomial on the bottom? What's the pattern? And then factoring is about working backwards and pulling apart that pattern, taking advantage of it to find the factors, right? So factoring is just like it's problem solving and it's thinking about those patterns. So I saw that's at least one person, probably several of you, saw the pattern in question A already. What is it? Like we've been doing dividing and factoring higher order polynomials, cubics, quartics. We can even go. Are you done? We could even go up to degree 5 or higher, I suppose, and we kind of know how to do all of that now. So there's a degree 4 polynomial. I could factor it like we did yesterday, but there's an easier way. What do you notice? Even if you don't see it yet, like how to factor this the easy way, there are things about it that should jump out at you. Yes? It doesn't have every term. Exactly. That's the kind of stuff that you start looking at. Okay, good. What else? Oh, what do you mean by the same as, oh, you meant the one way over there, that one. Ah. So this typical simple trinomial over here, x squared x constant, that first term, the exponent is twice the exponent in the middle, right? It's x to the 1, double that x to the 2. If we look at this one, it's x squared, double that x to the 4th. That's an important pattern. Number of terms is something that's really important to look at. In fact, in grade 10, when you learn to factor, that should be one of the most important things you notice about an expression like this. How many terms does it have? That's going to tell you almost everything you need to know about how you're going to factor it. That's in grade 10. It's not quite as true now, but in grade 10, if it's got 3 terms, you're trinomial factoring. Of course, you look for a common factor. Always look for a common factor. Always common factor first. If there's a 3 in everything, or 4 in everything, or 2 in everything, factor it out. Make your life easier, right? Don't forget to do that. But how many terms does it have? If it has 2 terms, in grade 10, it's probably a difference of squares, right? If it has 4 terms, there's another kind of factoring that it might be. And always look for common factor. So this one's a trinomial, and it has that pattern. So I can factor this the grade 10 way. 2 numbers that multiply to 12, and because the product, 12, is negative, they have a difference of the middle term. Not adding up to the middle term, but a difference of the middle term. So what are they? Two numbers that multiply to 12 and add to 1. Ross. 4 and 3. What do I put here to make this work? In grade 10, this is really tricky. This is really tricky for grade 10s. But it's just x squared, right? Because if I do x squared times x squared, I get x to the 4th. And then that one's positive, that one's negative, gives me the positive x squared in the middle. So I get negative 3x squared plus 4x squared is 1x squared. And I'm done. Often when you do these, this one didn't work out that way, although it looks like it almost did, is look if those binomials are factorable, right? That first one is almost a difference of squares. It's a sum of squares. This is not factorable, but it's almost a difference of squares. It could have been a difference of squares easily. Often they will be, like textbook questions or whatever, right? All right, good. Next one. So this next one, not a trinomial. It's got 4 terms. There's no common factor. So you might start looking for factors like we did yesterday. What could I sub into that would give me a remainder of 0 that would make it a factor? But there is actually an easier way. Factor by grouping, very good. This is something that, like, you learn in grade 10, isn't all that useful, but finally in grade 12, you start to see it more often. So factor by grouping. So how do we factor by grouping? Well, I take the first 2 terms. You might have to reorder the groups, but in this case, we don't. Okay, I take the first 2 terms, and I common factor them, and I get x minus 1. Then I take the second 2 terms, and it's not a matter of just common factoring them. Sometimes it might be, but in this case, if I common factor and take out a 4, it won't quite work. What do I have to factor out to make it work? Chad? Yeah, negative 4. So if I take out a negative 4, negative 4x divided by negative 4 is positive x, and positive 4 divided by negative 4 is negative 1, because these 2 brackets have to match, sign and everything. And so this is where, again, like, you have to problem solve. Factoring and common factoring isn't always about employing a rule. Sometimes it's about doing what is convenient, doing what's smart. Okay, and then I get x minus 1 and x squared minus 4 as my result. And x minus 4 is a difference of squares, so one last x plus 2, x minus 2. So heads up for those kinds of questions. That's a lot easier than doing the polynomial division and everything else. Any questions about either of those? Pretty straightforward. If you think you would have noticed that on your own, very good. But I think a lot of people would have, just because we haven't talked about it yet. So we noticed yesterday that degree 4 polynomials are a little bit trickier to factor, because you kind of have to do it twice, because what your result is a cubic, and we don't have an easy way of factoring degree 3 polynomials, so we got to do kind of it's a little bit faster, but we still have to like look for a factor and see if we can find one, that kind of thing. So it's a little bit trickier. But what do you notice about this one? Frank, what do you notice? Anything? You might be able to. Try it. I don't know if it'll work. It's got 4, like, there's lots of things to know. There's no right answer. It's got 4 terms. Frank's right. There are a lot of common factors in the first 2 terms and in the second 2 terms. Like, there's a lot going on there. Chad? You could certainly common factor an x out of every single term. Always start with that, because that decreases the original degree. That's going to make our lives a lot easier. Is there any other common factor in there? No, but there might be. In a future question. Okay, so now when I look at that, I think probably I'm going to have to factor this the new way. So we're going to say let g at x equal 2x cubed plus x squared minus 27x minus 36. So we're looking for something that makes g at x 0. So start looking. I mean, 27 and 36 are both multiples of 3, so 3 might be a good guess, but always try 1 and negative 1 first. They don't look like they're going to work to me. Something about it makes me think 2 might work. Negative 2. How many people have found one that works? 3 or 4 people. Diana, what did you find? Negative 3. Therefore, x plus 3 is a factor. So my original function wasn't called f at x, but I'm going to call it f at x equals x times x plus 3. So 3 times something has to give me negative 36, so that's going to be negative 12. X times 2x squared will give me the 2x cubed. And how do I find the middle term? Well, 3 times 2x squared is 6x squared, but I need 1x squared, so this is going to have to be minus 5x. So that I get negative 5x squared plus 6x squared gives me 1x squared, and I can check with my x's as well, which would be negative 15x minus 12x gives me negative 27x. So it works. And then I'm thinking that last bracket's probably factorable. So difference of 5, 8, and 3 is going to give me that. So I'm going to get 4 and 3. So that's going to be 2 times negative 4 is negative 8. And positive 3 times x is positive 3. Negative 8 plus 3 is negative 5. It's all about using what you know. Even that little process there. Both of those factoring, right? Getting this and getting this are just about using some common sense. Well, what has to be the case given the information that we have? Any questions? Pretty straightforward. Just a few things to watch out for. Okay, this is a bit of a different kind of question. This is the kind of question that textbooks love to ask. Draws from past knowledge. It's like across different units and multiple kinds of skills. It's the kind of question that I don't see how anybody would ever, like the first time you see it, how you would possibly figure out what to do. I don't know, maybe you would. I don't know if you had to, but I think it's the kind of question where most people read and go, I don't even really know what the heck it's asking me to do. But if you've seen it once, then, you know, now you'll recognize it. You'll be like, oh, this is one of those wonky ones. So what is it telling us? Let's think about what it's telling us. So if f at x is this guy, ax cubed plus x squared minus, I got my stupid thing on. Try that again. F at x equals ax cubed plus x squared minus 7x plus b. And when the remainder is 10 when it's divided by x plus 1. What does that tell us? That tells us that f at negative 1 will equal 10. Right? And then it also tells us when it's divided by x minus 3, the remainder is 46. That's telling me that f at 3 is 46. Right? That's remainder theorem from yesterday. Well, I can sub in negative 1 to this function. So f at negative 1 would look like this. A times negative 1 cubed plus negative 1 squared minus 7 times negative 1 plus b equals 10. So that's negative a plus 1 plus 7 plus b equals 10. So subtract 8 from both sides. That's going to get rid of those. And negative a plus b equals 2. I got a little equation there. Okay, next one. A times 3 cubed plus 3 squared minus 7 times 3 plus b equals 46. So that's 27a plus 9 minus 21 plus b equals 46. So 9 minus 21 is going to be 12, negative 12. So add 12 to both sides and I get 27a plus b equals 58. Does that look right? There's equation 1. There's equation 2. I have a linear system that I can solve and find the values of a and b. Who remembers how to do that? So I can do, I can subtract 2 minus 1. 27a minus negative a is 28a. B minus b is 0. 58 minus 2 is 56. 56 divided by 28? 2. Nice, that worked. Like it did, like the fact that it gave me an integer answer leads me to believe I probably did something right there. That's equation 3. Put 3 into 1. And so negative 2 plus b equals 2. Add 2 to both sides. B equals 4. Therefore, a equals 2. B equals 4. They wanted me to find the values of a and b that make the original statement make sense. So this would be like 2x cubed plus x squared minus 7x plus 4. Right? That's the original function. Oh, I'll leave that there for a second. Any questions?